Hi to all, and I welcome you to my YouTube channel Math Universe with Dr. Naseer Ahmed. Today we are going to start with chapter Linear Programming Problems. For this chapter alone, I will not be discussing the concept first and then solve the problem. But here, as and how I will solve the problem, I will discuss the concept. We have 3 questions, and in each model paper there is only one question. As you are aware, surely from linear programming problems, we are going to have surely one question. Okay, and henceforth I'll be calling as LPP. Okay, so let us take the first problem, question number 46 from model paper number 1. Question says solve the following graphically. As you are aware that graph sheet will be provided to you in annual board examination. They said maximize, and there are some of the terms given here. Let us try to understand one by one. First, if we just see, there is one function here. Z is equal to 250x plus 75 times of y. This we call objective function. This we call objective function. Now, what is objective function? It is a function of several variables, several linear variables which will optimize the given problem. I use two words, several variable, nothing but more than one variable. So as you can see, x and y are the two variables, and I also said it is linear. As you can see, degree of x and y, it is 1, and it is going to give optimum, nothing but either maximum value or minimum value. Both it will give. Depending on the question, we are going to talk about maximum and minimum. Now here they have given maximize, nothing but we have to find maximum value. If they could have given minimize, it will be minimum value of the corner points. Okay, so let it be maximize or minimize, there won't be any change in our problem. So I will try to comment for both at the end. Okay, then subject to the constraints, nothing but conditions, and here we can see we have got two constraints. One is x plus y less or equal to 60, other is 25x plus 5y less or equal to 500. This we call constraints, nothing but the conditions. And here most important, as you can see here also, degree of each of this variable is 1. That's what the chapter name, no? Linear programming problems. We are going to get all the function will be linear, and hence our diagram will be a straight line, because whenever the highest degree is linear, when I repeat, whenever the highest degree is linear, the geometrical presentation of that will be always a straight line. And this too can also be written as x comma y greater or equal to 0. So don't think that this is a printing mistake. Together we can combine x comma y greater or equal to 0, and this we call non-negative constants. Non-negative constants. When I say non-negative, it can be positive, real numbers as well as 0. And this guarantees that our solution is only in first quadrant. So how come? If you recall our Cartesian coordinate system, don't forget, as per our school days, our first quadrant have got both x and y to be positive. Always first quadrant is x, second is y. This is my y axis and this is my x axis. Whereas here, second quadrant, x is negative, y is positive. Third quadrant, both x and y are negative. Fourth quadrant, x is positive and y is negative. So the only one quadrant where both x and y is positive is first quadrant. When we say x equal to 0, y equal to 0, don't forget, equation of x axis is y equal to 0, and equation of y axis is x is equal to 0. So it's very clear that our answer will be only in first quadrant. So having this information, and throughout all our problems, okay, you can see all the NCERT problem, always this condition is specified, due to which our answer is in first quadrant. So we should also take the advantage of this, that when you are plotting the graph, if the numbers are huge, let us give more space for the first quadrant instead of second, third and fourth, because our solution region will be in first quadrant. So with this, let us start the problem. we are going to solve the inequalities. Now, let us for a while take the first inequality, that is x plus y less or equal to 60, that is our constants. I will be taking the equation. Now this represents a straight line. We know that only one line will pass through two different points. So you can just take some value of your choice. I prefer to take x equal to 0, then get y value, and y equal to 0, get x value, because the calculation will be simple. So I will regard this as equation number 1. When I am taking x is equal to 0, you can see it is here 0 plus y is equal to 60, or y is equal to 60 here. Similarly, when I take y is equal to 0 for the same equation here, you see we get x plus 0 is equal to 60, or x is equal to 60. Many times I have seen students, when they want to write point, no, they will write this one 60 60. No. When we are talking about a point, it is x comma y, x coordinate followed by y coordinate. So when x is equal to 0, we got y is equal to 60. So my first coordinate is 0 comma 60. And when y is 0, so be careful, when y is 0, what I got, x value 60. That's it. And if you want, you can form a table also and just put x value 0, then y value 60, and then y value 0, then x value 60. Okay. Now let us try to solve the next constant, that is here 25 times of x plus 5y less or equal to 500. And again I will be taking the equation. Now you can see, again same way, I will be taking, okay, first let us name this as equation number 2. Now when x is equal to 0, we are going to get in equation number 2, then here we will get 25 times of 0 plus 5y is equal to 500. I hope things are very clear. Now 25 into 0 will be 0. Then the remaining is 5y is equal to 500. Now divide by 5. So 5 ones are, and here 5 hundreds are. So y is equal to 100. Similarly, when I am going to have y is equal to 0, again in the same equation number 2, we are going to have 25 x plus 5 times of 0 is equal to 500. 5 into 0 will be 0. Remaining is 25x is equal to 500. When we divide by 25, we can see 25 ones are, and this will be 25 20s are. So now x is equal to 20. See, getting the value should not be a problem on dividing, because for PUC board examination, simple calculators are allowed for mathematics exam. I think for all the exam. Okay, so let us move on to next. So let's cross check. 2 into 25 will be 50. Yeah, 10, correct. And then 5 tens are 50 with 10. Yes. Therefore, the points here is when x is 0, we got y is equal to 100, and when y is 0, we got x value to be 20. I know there will be many students having a doubt, sir, why only x0, then get y value, then y0 x value, can't I take some other value? Yes, definitely you can take, and your answer will be same, but make sure, try to take some number which is big. I mean to say, don't take x is equal to 1. If you take x equal to 1, y will be 59. Plotting x equal to 1 and searching for 59 in the graph, it will be difficult. So that's the reason when the numbers are bigger, if you want to take some other number, then just take in terms of multiple of 10. When x is equal to 10, y will be 50. Okay, and similarly, once again, x is equal to 30. If you take for example, y will be 30. Now, even though points are different compared to this, but when you plot the graph, you will see all these points will be lying on the lines obtained by this. Similarly here. Now let us try to plot the graph. Let I erase this. I hope this point is clear why it is in first quadrant. Let I erase this. Let us have some space. Okay. So let us try to plot the graph this side, and as I said, the values are bigger and we are going to give the space for the first quadrant. I can take 1 unit is equal to 10 centimeter. So let us have, and there is no need of any scale reading, and as I said, give more space for first quadrant. Now along x value you can see 60 is the largest value. Okay, then along y axis, okay, along y axis 100 is the largest value. Fine. So let us go with 10, 20, 30, 40, 50, 60, 70. Undoubtedly in examination you are going to use scale pencil. Your presentation should be the perfect. And at least try to give one extra value. Okay. And I have seen many times when students are writing the numbers not 10, 20 in urgency, in place of 30 they will be writing 40, and as soon one value is missed, the entire graph will go wrong. Double check, have written 10, 20, I see 30, 40, 50, 60, 70, then 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, yes, and one negative value. Okay. Now coming to the first, and don't try to plot all the points at once. Try to plot one point and complete the graph. Now here it is 0, 60. Recall, or any point lying on x-axis is of the form x, 0. Similarly, any point lying on y-axis is of the form 0, y. So 0, 60 lies on y-axis, yeah, somewhere here. Yes, it's here. And 60, 0 x-axis, it is here. Let us try to join them. When you join, make sure go beyond first quadrant. Don't restrict yourself to first quadrant. This condition is only saying the solution should be in first quadrant. There is no condition on the line. Now whatever the line I have plotted, it is for this equation. Let us complete this one later. First let us try to get the solution region for this inequality. First I will write the equation, that is x plus y is equal to 60. Now let us write the inequality. It is given as x plus y less or equal to 60. Now we have to solve this inequality. Now this x plus y is equal to 60 has given the line, and now it is dividing the entire xy plane into two parts, above the line and below the line. Now you have to choose a point either below the line or above the line, your choice, but not on the line. If you take on the line, it will satisfy the inequality. Okay, and if you take whichever side you want, take. If it is satisfying the inequality, which one? X plus y less or equal to 60. If the point is satisfying, shade the same side where the point is present. If it is not satisfying, shade opposite to that point. For example, I'll take both the cases. Okay, for example, I want to take the point this region left of the line, and let us suppose the point I want this one, that is 20, 10. I have taken this point. Now let us try to put here, and we'll see whether this inequality is satisfying this point or not. So when I take x is equal to 20 and y is equal to 10, this inequality will give us 20 plus 10 less or equal to 60. 20 plus 10 is 30 less or equal to 60. Is this inequality true or false? Is 30 less or equal to 60? There are two things here, less or equal to. 30 is not equal to 60, yes, obviously, but 30 is less than 60, so it is true. Since it is true, I have to shade the same side where the point is present. Now before I go ahead, surely some student will have a doubt, sir, can I take some other point? Try to understand, there is no intention from my end. No, I want this point only. I can take whichever point I want, but left to the line presently I have considered. And as soon this point is true, you can take whichever point here, it will be again true. Value that 30 will vary, but it will be true. For example, let us try to take one more point. Purposefully, I am taking in this region to make it very clear. See, this region, second quadrant, third, fourth, as well as first quadrant, this part is all those are left to the line or below the line. So I will, even if I take this point, I should have the fact true only. Let us take here the coordinate x value is minus 10, y value is plus 10. So minus 10 comma plus 10. So let us try to put this value in this inequality and check is it satisfying or not. So if I take x plus y less or equal to 60, x is minus 10 and y is plus 10. Okay, x is minus 10 and plus is 10, y is 10. Sorry. So what will you get? Minus 10 plus 10 less or equal to 60. 0 less or equal to 60. True or false? 0 is surely less than 60 but not equal to 60. So one of the conditions satisfied. So it is what? True. See, here also true. Here also true and here also true. Both the time it is true only. Let I just correct this. It is overwritten because it should be easy for you to copy. Okay. Now one more doubt will come, sir. What if I take this side? Now that's what I said, no? If one point is satisfying the given inequality in a particular region, each and every point will satisfy. As you can see, 20 comma 10 satisfied and even minus 10 comma 10. Some might ask, sir, what about origin? Come on, put x value, y value, both 0. 0 plus 0 is 0. 0 is less or equal to 60. Therefore again true. Now what about this side, sir? Let us suppose you could have taken at the beginning this. Okay, and one more thing, since the first problem I'm going into so detail, next two I would like to just take only one particular point and go ahead. Okay, in exam also any one point is asked, not that you are going to take so many points. It is just to make you understand. Should not happen, no, that you have got doubt. Sir has taken his own coordinates to shade the region. It can be any, but it should not lie on the line. That's very important. If you take any point lying on the line, for example here 60 comma 0 is lying on the line, just see 60 plus 0 will be 60 itself. It will satisfy. Then you cannot shade below nor above. Now if I take a point here, let us see which point. Okay, let's say 50 here, and you see carefully, there is a point 50 and suppose somewhere here I am taking, okay, till 70. And purposefully, I am taking a point bit far. I am not taking any point very near to here. Also I can take, okay, here or here. Why am I not taking near? My graph is rough graph because I don't have a graph sheet here. But when you are plotting in examination and for practice also when you do, since you are going to plot in the graph sheet and your line is accurate, then you can take a point very near to the line but not on the line. Okay, then also you get same answer. Now you see this coordinate we have taken. Okay, so it is going 50 comma 70. Fine, 50 comma 70. Yes. Now before solving itself, I'm saying we should get false. Why? As per the concept, as soon one side point is agreeing, other side point should disagree with the inequality. Let us take the inequality here. X plus y less or equal to 60. So x value is 50 and y value is 70. So let us substitute here. X is equal to 50 and y is equal to 70. Okay. Now when I put here, this will give us, this is 0. This will give us 50 plus 70 less or equal to 60. 50 plus 70 is 120 less or equal to 60. Is this true? Is 120 equal to 60? No. Is 120 less than 60? No. It is false statement, which we already came to know. So now why I did this? To make you understand, in case of taking the point below, if you could have taken above and if this is not the solution for this particular inequality, you will get what? Something same like this, false. As soon as it is false, my answer is opposite to the point, nothing but below the line. If it is true, like in this case, for example 20, 10 and minus 10, minus 10 and plus 10, since it's true, I have to shade the region towards the point. So you can take any one point. True, shade the same side. False, shade opposite to the obtained point. Okay, the point which you have chosen. Okay, so you are free. Okay, and in place of shading everything, to avoid confusion, what I suggest, just give an arrow mark like this. This arrow mark is saying that for this line, my solution is below the line. Enough. Don't shade too much. Just keep like this. Now we have finished the first inequality. Now coming to second inequality, 0, 100, that is here on y-axis, and 120, 0. It is 20, 0. It is here. Now let us join them. Okay, it is let's say here. So now after having this, let us try to know for this line which is the solution region. Okay, for that let us take this first, the equation letter, right? I am writing it here. 25x plus 5y is equal to 500, and then the inequality here, 25x plus 5y less or equal to 500. Now I have to choose a point for this line. See, if you are trying to plot the, let us just comment this. Let us suppose you are going to plot all the points together. Then I have seen many times, in place of joining this 2 point, in hurry, student join this point and this point. Similarly, in hurriness, in place of joining this, they might join this. That's the reason I am saying plot one graph at a time. Shading part let you complete. Then go for the next graph, where you have got minimum chance of doing error, or I can say there won't be any error. Now for this line, should I take left point or right point? Your choice. Do you want to take same point? Your choice. But if it is true, shade the same side. If it is false, shade the opposite side. Now for this, if I say, let us suppose left, I will take here for example origin. So x is equal to 0, y is equal to 0. 25, so this one will become now 25 times of 0, then plus 5 times of 0 less or equal to 500. 25 into 0 is 0, 50 into 0 is 0, less or equal to 500. 0 plus 0 is 0, 0 less or equal to 500. Is this true? Yes, it is true. Therefore, I have to shade the same side. So, I'll take one more point to demonstrate. Okay. Let us suppose I'll take a point here with respect to this line. So, the point is from here 30. And let us suppose here I'll take 60. As I said, I'm taking a point bit far because my graph is rough graph. So, it is 30, 60. Now, since left of the line it is true, right of the line should be surely false, and you can see that one here. Now again for this, if I'm going to substitute here in this inequality, so x is equal to 30 and y is equal to 60. When I'm going to substitute here, I'm going to have 25 into 30 plus 5 into 60 less or equal to 500. So multiply 3 5s are 15, 3 2s are 6, 7, then 1 0, 5 6 are 30 with one more 0. Calculate is allowed for you in your final board exam. 7 plus 3 will be 10, so 1050. Is 1050 less or equal to 500? Is this true? No, it is false. That's what I said. Since already you got for 0, 0 true, or whichever point you have taken left of the line, you will get true only. Okay, and that means right of the line it will be false. So for this line also, my solution region will be left of the line. Now let us try to, I just want to put one point across you. Without solving this also, you can judge which side the line will have the solution region. But for that, xy in the left hand side should be positive, means multiple, and right hand side constant should be positive. But for PU board, as per the scheme, we have to work out for the marks. But just to know, how this trick works, just know if all x multiple positive, y multiple positive, and constant in the right hand side is positive, if that's the case, then you have to follow this inequality. Less or equal to means towards the origin. Origin you can see here, towards the origin. Here also what we have, less or equal to, so it is what? Towards the origin. So whenever you have got less or equal to, that's will be what? Towards the origin. And if you have got greater or equal to, it will be away from the origin. For example, if I have got the question as greater or equal to, then for this particular line, my answer will be towards the right, but you don't apply in PUC, let you do in step and get full marks. Okay. And we'll be also taking one problem where the line is passing to the origin, then this criteria, whatever I'm just saying, the trick will not work. We have to take the point like this and solve it. For PU board, it is mandatory. I'm repeating again, you have to solve, but not so many, any one point. Okay. Now, feasible region. What is feasible region? So far I've just said solution. When I say solution, for this inequality I'm saying, two inequality. When I say feasible region, it is a solution for all the constants, both this constant as well as non-negative constants. So I want only in first quadrant because of this condition. So no need to search in second, third and fourth. Just you see where both the arrow marks are meeting. Just see carefully. For this line, the arrow mark is coming towards the left. For this line also towards the left. So ultimately for this, it is this particular region. And I would suggest you to highlight like this. It will be so good for the evaluator, no? That, oh, so students knows very well. And then you shade here. Make sure don't shade outside this polygon, the quadrilateral which you have got. And comment here. What is this? This is bounded feasible region. Bounded. Why? From all the side, the lines are there. I cannot go out. If I just leave an ant here, for example, when it goes here, there is a stop in this side. Come here, stop. Come here, stop. Come here. There's a border there. So bounded feasible region. Okay. Now the solution for this problem, the maximize or minimize concept says it will be at the corner points of the feasible region. When I say corner point for a bounded figure, as soon as we say it's a bounded, it's a polygon. Vertices are our corner points. Now, which are the vertices we have? So, as you can see, coming to the vertices, yeah, origin. So, 0, 0, my first vertices. I can say corner points also. Then A, and this is lying on x-axis. So x1 is 20 here. Y value will be 0. So this will be 20, 0. And here also we have a point of intersection. If we had graph, we could have just see vertically down. And here, the graph, the way I have drawn, it is looking like 20, 50. Let us just see, is it 20, 50? No, it is not 20, 50. It is not satisfying this. So I have to compute, but in graph it was there. Surely you can solve it. So we just see what's the value for this. We have to find, and here it is 0, 60. So this is the coordinate C. So only B I have to find. Okay, first you can go through this. You can make a note. I'm going to erase this side. I have to plot the table. Okay, erase this side. That I not erase the question. Only this part I will erase. Now see the problem which I have taken, means given in the model paper. Surely if at all the solutions are natural number or the whole number, surely from graph you should get. Okay, now it's a rough diagram. So I will take this opportunity of solving. Let us recall how are you going to solve system of linear equation by elimination method. because one problem is there in PU board also where your answers are fraction. So let I just solve it here, and then we can complete the table part here. Okay, so here I'll just take the equation x plus y is equal to 60, and here if I divide by 5 for this part, if I divide by 5 the second equation, I'm dividing by 5, then I will get 5 5s are 25, then plus y is equal to 5 hundreds are 500. Yes, now elimination method is what? Change the sign here. If you have plus, change to minus. If you have minus, change to plus. Plus y minus will get cancelled. X minus 5x will be minus 4x, and this will be minus 40. So 4 ones are 4 tens are. So we are going to have x is equal to 10. Okay, x is equal to 10. So that we are not able to see because diagram is rough. Similarly, if I just take this as equation number 1, already we have taken, no? So if I put this value in equation number 1, we are going to have 10 plus y is equal to 60, or y is equal to, when we transpose here, we get 60 minus 10, nothing but y is equal to 50. Therefore, the point of intersection is 10 comma 50. That is this point, and we can easily verify whether it is correct or not. If I substitute, both the equations should satisfy because it should lie on the line. So you can just see x is equal to 10, y is equal to 50. 10 plus 50 is 60. Yes. Then 10 into 25 will be 250. 5 into 50 will be 250. 250 plus 250 is 500. Yes. Now let us complete the corner points. But as I'm saying, when you could have did graphically with the graph book sheet, when you just see down, surely you will see here 10, and when you should see here it will be 50. 50 you are able to see. Okay, fine. Now let us take the corner points. And the value of z. Now we are using the objective function. Now the first corner point is origin, that is 0 comma 0. Let us complete the table. Let us substitute 250 into 0 plus 75 into 0. So answer will be 0 itself. Next, 20 and 10, second corner point. So let us simplify. 250, this is your x value and this is your y value. Okay, so put here 250 into 20 plus 75 into 0. 2 into 25 will be 50, and with 2 zeros, 75 into 0 will be 0, so the value is 5000. Next, if we take the next, the corner point 10 comma 50, b value is 10, here it is 50 there, x value is 10, y value is 50, put here in objective function 250 into 10 plus 75 into 50. 25, okay, into 1 is 25, and there are 2 zeros here. Then 5 into 5 is 25, borrow 2, 5 some 35, 36, 37, and we have a 0. Add this, when we add 0, then 5 plus 0 is 5, 7, so it will be 12, then 3, 3, 6, 6250. The last thing we have, the last corner point, that is 0 comma 60. So when I take 0 comma 60, x value is 0, so 250 into 0 plus 75 times of this value, again 60, so I can substitute here. So 250 into 0 is 0. Here 6 5 is 30, borrow 3, 6 6 are 36, 42, 42, 43, 44, 45, 450, and since we have 1 0, we can have one more. So anyway, this calculation you can do by using calculator. I have not pre-calculated all, that's the reason I am calculating one by one. Till here, whether it is maximize or minimize, no change. Now since the problem is asking us to get what? Maximum value, that is maximize, nothing but I want that particular corner point which will give maximum value. Concept says the corner point of this feasible region will give us maximize as well as minimize. So see the largest value among all this, the largest value is among 0, 5000, 6250 and 4500 is 6250, and it is occurring at this corner point B. Therefore maximize is this. So at the corner point 10, 50, let us comment that. Therefore maximum, write in other color, value is 6250 at the corner point B 10, 50. But let us suppose the question here in place of maximize they could have given minimize, then which is the least value among all this? 0. At which corner point? 0, 0. That the comment will be there if it is minimize. Kindly make a note of this. See, mark distribution will be like this. Solving this 2 inequality which we just erased will carry along with the graph will be 2 marks. Then identifying this 1. Okay, solving those 1 and then table along with the solution 2 more. Totally 6 marks. Kindly make a note of this. Yes, let us move on to the next problem. And this question is from model paper number 2. Question number 46 for 6 marker. Solve the following graphically, and this time it is minimized, okay? And we have been subject to z is equal to 200x plus 500y, that is our objective function. And again we have got 2 constants here and here non-negative constants. This time I am going to solve. I will not be taking too many points. For each constant I will take only 1 point. The motive of taking so many points in the last problem was to make you understand that you are free to take whichever point you like, okay? But only you have to not take any point lying on the line. If not, it will just satisfy. So you cannot shade either above or below the line, okay? Now let us move on to the problem. This time the constants which is been given, it is x plus 2y that are equal to 10. If I take the equation x plus 2y is equal to 10, in place of solving the way we did, we can also take tabular. Here it is x value, here it is y, and here it is the coordinate. This also can be done if you are good in oral calculation. So when I say when x is equal to 0, I prefer 0 because calculation will be simple for us. When this is 0, we are going to get 2y is equal to 10. So when I say 2y is equal to 10, 2 1s are 2 5s are, so y value is what? 5. So yeah, 5 here. So this will be 0, 5. Similarly, when y value is 0, 2 into 0 is 0. So I'll get x plus 2 into 0 is 0 is equal to 10, or x is equal to 10 here. So always x first, then y coordinate. So I'll get 10, 0. This time the values are quite small. Moving on to the next. Here we have 3x plus 4y less or equal to 24. So here we have 3x plus 4y is equal to 24. So now let us take again the values and see this x value, y value 0 you can always take whenever your constant is non-zero. If it is 0, we'll take next model paper, there I will be talking about that. But whenever it is non-zero, always we can think of taking the values to be 0. So again, when x is equal to 0 here, you can see 3 into 0 will be 0. Write it here. Then plus 4y is equal to 24. 4 6 are 24. So y is equal to 6. Then when y is equal to 0, 4 into 0 is 0, so we can just have here 3x, and this is anyway 0, is equal to 24. So 3 ones are 3, 8s are 24. I just took a table this time, so that now in case you have a doubt, why not table? Yes, for this you have to have table on the way previous problem we did left to you. Okay, no one is going to have any objection on that. So having all this, let us proceed now. So this time the values are quite small. So, and when it's small, no, don't try to make your scale reading big, like for, I can say, no, 2 units you're going to go beyond. Let you maintain as 1, 2, 3 itself. Okay, so just see here. So along x it is 10, along y, okay, also I will take 10. So it will be a very small graph. This time it won't be so big like last time. So here let's say 1, then 2, 3, 4, 5, 6, 7. We want till 10. Let us extend the x-axis. 8, 9, 10, and we can have one more value 11. No problem. And here also 1, 2, 3, 4. So largest value is along y-axis. Okay, we can stop at 7 because largest is 6. So even if you write more, there is no use of that. Yeah, now here 0 comma 5, as you know, any point lying on y-axis is of the form 0 comma y, and any point lying on x-axis is of the form x comma 0. So 0 comma 5, yeah, it's here, and 10 comma 0, it is this. Let us join this. And as I said, always try to extend beyond the first quadrant, and for this the equality is x plus 2y is equal to 10, and the inequality is x plus 2y more than or equal to 10. We are free to choose whichever point we want, either below the line or above the line. So let us say one point we will take. Okay, let's say this one, 2 comma 1. This line is below the line. So when I take x is equal to 2 and y is equal to 1, we are free to choose the point. There's a point here, 2 comma 1, but it should not be on the line. So we are going to have 2 plus 2 into 1 on this. I am just substituting. I am getting here greater or equal to 10. 2 and 2 into 1 is 2. 2 plus 2 will be 4. Is 4 greater or equal to 10? Ask yourself. 4 is greater than 10? No. Is 4 equal to 10? No. It is false. So as we discussed in the previous problem, if it is true, shade the same side. If it is false, shade the opposite side. So since the point is here and I got false, I am not going to shade here. I am going to shade opposite to the point. So my shading side will be this. So this time I am not taking too many points. So it also means that if you could have taken the point here, surely it could have been true. Now let us take the next line. Let us plot. Here it is 0 comma 6. Yeah, it's this. And 8 comma 0. Make sure this part, let it come in the graph side. Okay. Now when I'm going to join this, okay, so having this this line, so for this let us take the, okay, I'll do it here. Let us try to see the inequality. So first the equation that is given as 3x plus 4y is equal to 24, or 3x plus 4y less or equal to 24. Again we can take a point for this line either below or above. Below or above we can take. So for this line, let us suppose, even if you want, we can take the same point. Okay, same point also we can take. So let's check some difference. So let's say 4 comma 1 here, or 2, yeah, 4 comma 2. So x is equal to 4 and y is equal to 2, which is the point we have taken here. When I substitute here, I'm going to have 3 into 4 plus 4 into 2 less or equal to 24. 3 4s are 12 plus 4 2s are 8 less or equal to 24. So this will be 20 less or equal to 24. And is this true? Check it out. Is 20 equal to 24? No, but 20 is less than 24. Yes, it is true. Since it is true, I have to shade the same side where the point is lying. Point is lying here. So for this line, I'm going to shade here. Okay. Don't forget, my diagram is rough diagram, but when you do graphically, you will get exactly the point. Now, actually, here, if you just see, like this, you are going to see. See, if you see down, so here, in your graph, 4 will be present. So I'm just removing and putting here. So 5 will be somewhere here, etc. So I just verified before taking the problem. But you can see at least the y value is coming in here. So this is what you are going to see in your graph, that there is no need to solve. When you just see perpendicular down, you will see 4 value here, and here it will be 3. Last time also you got integer, and without solving also to the graph you can get that. So your x value is 4 and y value is 3. As I said, I have already checked the solution, and even you can just check x equal to 4 and y equal to 3. If you substitute, it will satisfy here. 4, then 2 3s are 6, 6 plus 4 is 10, and here 3 4s are 12 and 4 3s are 12. 12 plus 12 will be 24. Now I have to talk about the feasible region. So just see which side we have got both the arrows. If you see this, it's going above and it's coming below. So this is nowhere, nor here we have common. But when you see here, for the above line is coming below, but for below it's going above. So this is also not. Similarly, this is also not. Only for this line is going. This is the solution region, but not for this. But if you see carefully this part, if I highlight in blue color, this particular region bounded by these 2 lines, you can see both the arrow marks are converging. They are coming to the same region. They are pointing the same solution region, and hence this is my bounded feasible region. Bounded feasible region. And the corner points is here A, and then you see one more corner point, nothing but my vertices. This is 6 on y axis, so it should be 0 comma 6, because on y axis x is always 0. And one more point we have got here C. I will take this, and it is 0 comma 5. So these are the corner points, and for this we are going to find the table. Let's try to complete here. So here we are going to have corner points, and the first corner point is A, 4 comma 3. And one more thing, there is no such rule that the thing should be in this order only. I could have taken this as A, this as L, this as M. Okay, naming can be in any way, but the point should be the same. Okay, point will be the same for the given problem. And my objective function is here. So z is equal to 200x plus 500y. Yeah, numbers are a bit big to calculate, but don't forget you have calculator advantage. Now this is my x value and this is my y value. Substitute here. 200 into 4 plus 500 into 3. 2 4s are 8 with a double 0. 5 3s are 15 with again double 0. So you get 0 0, and we get 2300 for this. Am I right? 8 16 24. So one less. Yeah. Next corner point is 0 comma 6, and you can take in any order the corner points. There is no fixed rule that since I have taken in this order you have to solve the same order. You can take the 3 corner points as per your order and convenience. 200, x value is 0, y value is 6, substitute here 0, and 500 into 6. 200 0 is 0, 6 into 5 will be, write it here, 0 plus 6 5 are 30, 2 zeros, so answer will be 3000. Now we are going to for the last one. Last one is 0 comma 5, so corner point C 0 comma 5. Let us solve that. So 200 into 0 plus 500 into 5. 5 5 are 25, so here it will be 0, then 25, and then double 0. So this is 2500. So I just made attempt that all together. No, it should be in one working. Now after completing this, come back to question. Minimize. What's the least value among this 2300, 3000 and 2500? The least value is this, and it is occurring at this corner point. Therefore my comment will be, let us write the comment here. It should be below the table, but since space is not there, I am writing the comment here. A cloud. Okay. Minimum value is 2300 at the corner point A 4 comma 3. See, as an evaluator, we are least bothered about this order and alphabet, correct? So let's suppose you have got 0 comma 6 written here or here. This value we should get in the same row. That's what I mean to say. Should not happen. No, since I went in this order, you also have in the same order. Point will be the same, but the alphabet representing the coordinate may not be the same. But for this 4 comma 3, yes, for this problem, same value we should get. So hence minimum value is 2300 at the corner point 4 comma 3. With this we have come to end of model paper number 2. Now we have one more model paper, that is 3. Let us take that. Now we are with model paper number 3, and this will be the last problem from linear programming problems chapter for 6 marker. Question says solve the following graphically. We have to minimize and maximize. As in the first problem we discussed both, right? So we have got together, and the objective function is given as z is equal to 3x plus 9y, subject to the constants x plus 3y less or equal to 60, x plus y greater or equal to 10, and the new constants compared to last two problem. This is the new constant, that is x less or equal to y. Okay, so we have got one new constant compared to last two problem, and this is non-negative constant. The only guarantee about this is the answer will be in the first quadrant. Now again let us go with the same. So first I will take x plus 3y less or equal to 60. I am taking the equation x plus 3y is equal to 60. So equation number 1. When x is equal to 0, I get 0 it is. So I'll get 3y is equal to 60. 3 1s are and 3 20s are. So y is equal to 20. Whereas when y is equal to 0, we have x plus 3 into 0 will be anyway 0 is equal to 60 as it is. So x value is 60 here. Therefore, when x is equal to 0, we have got y value to be 20, and when y value is 0, x value is 60. Okay. Now let us also take this one, x plus y greater or equal to 10. When I take x plus y equal to 10, for here when x is 0, you can see y is 10, and when y is 0, you can see x is again 10. Therefore from here the coordinate will be when x is 0, y is 10, and when y is 0, x is 10 again. So this one we'll try to plot after we plot this two, including the solution of this. Okay. So along x-axis 60 is the largest, and along y it is 10. So we cannot think of taking 10, 20, it will be a very small graph. So we can do one thing as 5, 10. Yeah, that will be better. 5, 10, 15. So let us go for that. So along y-axis it is 10. Okay. 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and here let us have 60. This is your x-axis. So yeah, along y it is 20 is the largest, so it does have the same 5, 10, 15, 20, 25. Enough. Okay, let's plot. 0, 20 lies on y-axis. So just see 5, 10, 15. Yeah, nothing is missing between. So 0, 20 here. And 60, 0. Surely you have to use scale and pencil in examination. Only then you are going to have accurate graph. It should not be like this, no, without using scale. So when I'm going to just join this. Now for this, let us have the equation first. The equation is x plus 3y is equal to 60, and the inequality is x plus 3y less or equal to 60. So for this, we can take a point either below the line or above the line, left to our choice. So let's suppose I'll take a point here, that is 10, 5. So when x is equal to 10 and y is equal to 5, this will become 10 plus 3 into 5 less or equal to 60. 10 plus 3 5s are 15 less or equal to 60, or 25 less or equal to 60. True or false? It is true. 25 is less than 60. Yes, it's not equal to 60, but we have option or. So it should be shaded in the same way the point is lying. So first problem I took so many points, I think more than 2, to make the concept clear. So as it is true, shade the same side. False, shade the opposite. Now let's see. 0, 10. 0, 10 is on y-axis and 10, 0 is on x-axis. Now let us join this two. Okay, always try to extend above, beyond the first quadrant. Okay, for this again, let us say I am going to, here is the equation. Always see this entire thing you can do what I am doing here on the graph except the table. Okay, so here it is x plus y is equal to 10. Then we have the inequality given the question is this, so x plus y greater or equal to 10. So I have to choose a point with respect to this line either above or below. Let us suppose I take a point above or left our choice. Let us say I'll take 0 origin here. So x is equal to 0, y is also 0. Then what happens this? 0 plus 0 greater or equal to 10. I'll get 0 greater or equal to 10. Is 0 more than or equal to 10? Is 0 more than 10? No. Is 0 equal to 10? No. So it is what? False. Whereas here, so since for x plus y greater or equal to 10, we have got false, and we have taken the point here, the origin, so it is false. So I have to shade opposite side, opposite to the line. So here we have got the solution for the second inequality. Now when we consider this one, x less or equal to y, I want you to understand one point here. As I discussed in the previous one, that if at all xy multiples are positive, always we can further inequality less or equal to. So you can see for here less or equal to and here greater or equal to, so it is more than or equal to. But same thing is not going to be true here. This says towards the origin less or equal to, this says away from the origin. But this is free from the constant. Constant means this, not a multiple of a variable. Here 3 is a coefficient. It's a constant, but it's a coefficient because it's a multiple of variable y. Here x multiple is 1, so coefficient is 1, and here x and y coefficient is 1. Here the constant is 0. Whenever for any polynomial constant is 0, it will pass to the origin. And you can see here also that if I take x is equal to y, when x is equal to 0, y is also 0. Now if I take y is equal to 0, I'll get again x equal to 0, I'll get only 1 point. Through 1 point, infinitely many line can pass. So I have to choose one more point. You can take one x value from here. Let us suppose we take 20. So when x is equal to 20, you can take whichever you want. Y value is what? 20 again. So my points are 0, 0 and 20, 20. So 0, 0 is here and 20, 20, yeah, it's here. Now I can join this. Okay. Now let us try to know which side we have to shade. Now less or equal to towards the origin and away from the origin is gone because line passes through the origin. So we have to shade. So means we have to take a point and know x less or equal to y. Before that, the equation we can take whichever the point we want. Let us suppose we take this 10, 0. So x is equal to 10 and y is equal to 0. So when I put here, I get 10 less or equal to 0. Is 10 less than 0? No. Is 10 equal to 0? No. So this is false. Since it is false, I have to shade the opposite side. So the point was taken here. It's false, so I have to shade the opposite side. So I should not shade this side. I should say shade above. Now let us see our solution region, but feasible region, solution for all, and this guarantees it is first quadrant. And actually I think you can also write, as I said, like this also, both are same. Okay, now you see, coming to this region, it is solution for this line and this line, but not for this. Whereas here you can see only for this line is coming down. Here also you can see only for this line, and this line is coming to this region. But whereas this, for this line arrow mark is there, for this line also arrow mark is there, and for this line also arrow mark is there, and it's in first quadrant. So this is my bounded feasible region. Now we should know the corner points. So one corner point you can see from here, and here I can just say, let us write in blue color so that the visible is clear. So here it is on y-axis, so the point will be 0, 20. This is the coordinate A. Okay, whereas here I will take this coordinate and it will be 0, 10 because lies on y-axis. So here graphically what you may get, so I just check from here 5, 5. Yes, graphically when you are going to see, here it is 5 and here also it is 5 when you are going to plot graph. So this will be 5, 5. So I will take it here. So it is C, the coordinate is what? 5, 5. And similarly when you see, it's looking like 15 and 15. Let I just cross check. 3 into 15 is 45. 45 plus 15 will be 60. Yes. So approximately you can just see. So if I just go down, it is 15 here. And again here also, when you just go this side, yeah, it is 15. So x1 is also 15, y is also 15. That through the graph you can see when you plot. So I have got all the concepts. I would like to just highlight this point. What I am trying to say here is, let us suppose that we have got a point here and whose coordinates are x, y. So as soon as I got this, I mean to say I don't know this, correct? No, but I got a point. So what I am saying is, just go down perpendicular, and here also perpendicular. You will get here x value, and here you will get y value. So since this x and this y together will form a x, y. I hope this point is clear. That's what I am trying to implement. Now let us take the table, the last part of the problem. We are almost done. So corner points. And then the objective function z is equal to 3x plus 9y. And now, which are the corner points? The first corner points A. 0 comma 20. So x value is 0 and y value is 20. Put here 3 into 0 plus 9 into 20. 3 into 0 will be 0, 9 into 20 will be 180. So the addition of this will again give us 180. And I extend the table. So first value is done. Moving on to the second value, b 0 comma 10. X value is 0, y value is 10. Put here 3 into 0 plus 9 into 10. So answer is 0 plus 90. So value will be again here. Okay, here is 90. Moving on to C 5 comma 5. Put it here 3 into 5, then 9 into 5. 3 5s are 15, 9 5s are 45. So value will be 60 here. Now the last coordinate 15 and 15, that's D coordinate. So now we can just see here 3 into 15 plus 9 into 15. Okay. So now 3 into 15, 3 5s are 15, 3 1s are 3, 4, whereas 9 5s are 45, 9 1s are 9, 10. Okay, 135. When you add this, let us write it properly, it's 135. When you are going to add 5 plus 5, 10, then 8, 180. Is it right? 4, 5, 6, 7, yeah, 8. Now come back to the question. This time they want minimize also, maximize also. What is the minimum value? Least of 180, 90, 60 and 180. 60 is the minimum value. What is the largest of all? We are getting 2 points to be largest. This also maximize or maximum, and this is also maximum. So we have got 2 points to be maximum. Let's conclude here. Therefore, minimum value is 60 at the corner point C 5 comma 5. That's what we can see here, 60 at 5 comma 5. And coming to the maximum value, is 180, and it is at 2 corner points at A 0 comma 20 and here D 15 comma 15. Okay, this is and. So I just want to highlight one point. Problem is completed, but here I am getting 180 at 2 corner points. Let us see where are those. A 0 comma 20, it's here, and one more is 15 comma 15, it's here. Now what I want to comment here is a very important point, that whenever two consecutive corner points give same maximum value, so in this case 180 is the maximum value at A and D. From the graph there you can see it is a consecutive point. So each and every point lying here on this line of the feasible region will give you same maximum value. It's not that here will not get the same maximum value and here, yes, you will get, but those points are not useful for us because those are not points lying on the feasible region. So this point, each and every point will give us same maximum values there. If you just want, I can just take one value. So because I don't have graph, no, so without graph I will just analyze here. This is the equation. When I put x is equal to 10, transpose here, I'll get 50. So 50. So it will be a decimal. Let I give you some integer value for 5. What will happen? Yes, For 5 we'll get 55. Okay, we'll get some decimal value itself. Okay, fine, but you can take and just cross check that. So with this we come to an end to the chapter linear programming problems with respect to the model paper. Here this region, solution for all, we call feasible region, whereas this region, which is not the solution, we call infeasible region. Okay, so I have completed all the 3 model paper, and from this chapter surely one 6 marker is sure. So all the very best, study well, give your best. Thank you. Dear students, having completed all the 3 model question paper problems from the chapter linear programming problems, it's a time for the assignment. As we know, if you do the assignment, only then we become perfect. So these are the assignments from exercise 12.1, and I have given the same numbering as per the NCERT text, so that after you solve, you can compare from the textbook the solution given the behind. Be careful, apart from question number 2, 7, 8, these 3 questions you will get natural number answer, but for question number 3 you will get a fraction. Okay, it will be a decimal, and it will exactly match with the NCERT textbook. So all the very best, do well, make sure do the assignments. That's the key for the success. All the very best, work hard and study well. God bless you. Thank you. Please share the video, like and subscribe. Thank you very much.